Hello, everyone. Welcome to ITS 140. So we continue our discussions of programming. Last week, or rather on Tuesday, if you remember, I introduced the topic of dictionaries. We went over dictionaries, sets, and the pickle module for serialization of data structures, basically, or data. Today, we're going to continue with a new topic called, and you can see here, you should be seeing the bright space, and you can see here, covered object-oriented programming, Python dictionaries, and actually I did this like that. All right, so today I'm going to go over the topic of object-oriented programming. So we'll do the same, as I said, going forward, we're going to do the same approach that I did on Tuesday, which is I'm going to introduce a new topic. We're getting very close to the end of the semester, so I really just want you to focus on the project. These are advanced topics. So what I'm going to ask you to do is the same thing. Today, I'm going to introduce object-oriented programming example. And then after that, I'm going to, create the breakout rooms again and just make sure that everyone is introducing this new topic into the term project. Okay, so the idea is that all of these, we're going to talk about what you could do. Excuse me. And then I want to see you guys introduce these topics to the term project. All right, so first thing I will do is go over these two slides today. Okay, so let me switch over to the slides. So currently the topic is chapter 10 of the new book. I'm going to share the document here in a second. All right, so you should be seeing the slides now, okay? And so we're gonna go over this concept kind of slowly. Don't worry about this topic being it's abstract, right? So it's an abstraction of code, and so it might be a little bit more confusing. Don't worry so much about it right now. You're going to see object-oriented programming in many courses in the future, and after a lot of repetition, it'll just start making sense. So I wouldn't worry. And remember, we're just going to look at it from the point of view of Python. So there's a lot of programming languages out there that that can use object-oriented programming. The ideas are similar. They all have somewhat more different implementations of it. And I think in Python, it's got its own unique one with its own little specific things, but it's a good way to learn the language, or sorry, the concept initially, okay? And it is highly used. A lot of the modules that you use whenever you do an import of a module, they're object-oriented. And you've seen already that a lot of things in Python are object-oriented. For those of you that at some point have an interest in data science, you'll see that a lot of algorithms are written in object-oriented approaches and in many other fields as well. And so it's pretty good. All right, so the topic is, object-oriented is called object-oriented programming. Here, the name is actually classes and object-oriented programming. So let's kind of dissect this into all the keywords here. So I would say that object-oriented programming is the high-level concept. And then classes are a construct within object-oriented programming that allows you to develop objects. Now that's the focus of object-oriented programming. You've already you've done this. I mean, you're all working on the project, right? On a project of some kind. Let's say that you're building a system that, you know, will store inventory, right? Inventory about hammers and nails and things like that. So you're already thinking in terms of records because you know that all the information is related. You know that, you know, there's the ID, there's got to be a unique ID in the system for every product. Otherwise, it would be impossible to find anything. And then there's got to be specific names like hammer, nails, but there's also quantity. There's also price, that, you know, a lot of things, right? A lot of information, more descriptions about the products, etc. And so that's what object-oriented programming kind of is. It's a formalization of something you were already doing. You were already sort of thinking about, well, these are products somehow. But then I also want information about people. So these are people issues. And so wouldn't it be now, you know, of course, I introduced dictionaries on Tuesday, and that's a way of storing information as well and of organizing it. But object-oriented programming is just a higher level of that. So you create objects that don't actually exist in the system. Okay, so that's really what you're doing. You create objects that don't really exist in the system. You know, so you have a dictionary, but you don't have an object called, you know, persons or people, or you don't have an item called inventory items, right? But even though you don't have those in the language, you can create those, and you can create them, and they can be very complex structures, basically. Okay, so that's kind of the idea. So let's go through the slide. So the topics that we're going to cover are procedural and object-oriented programming. Just kind of, I've talked about that. You know, what are classes within that specifically? An instance, right? So an instance, so you have in an object-oriented programming, you have the definition of something, and then you have the use of it. It's like, the best example that I can think of is, let's say that you're building a boat. You're building a wooden boat from scratch, right? You're gonna take a hammer, nails, saw, power tools of some kind, and you're gonna build that boat. But how are you gonna build it? First, you need to have a plan, right? You need to have a blueprint of that boat with instructions and everything. So in a way, that's kind of what the difference between the definition of a class or an object in Python and then the instance. The definition is like the blueprint. You define everything, everything is built. And then, but there is no actual boat yet. When you create an instance of the boat, it's like, okay, now you're gonna out of nothing materialize a data structure in memory that has the blueprint of that object that you just created. Okay, so that's kind of an intuition of it for now. As I said, these concepts will come to you. There's a lot involved in object-oriented programming. So, you know, and then finally, the last bullet there, or the last donut, I should say, is techniques for designing classes, right? So that, you know, that's really what this is about. And that's why I think it's really good to do this with the term project. So procedural programming basically means writing programs made of functions that perform specific tasks, right? Or some people would call it modular programming as well. So procedural, modular programming, writing programs made of functions that perform specific tasks. That was one of the early subjects in the semester, and throughout the semester, we've been using that a lot. So you should be familiar with those concepts. So procedures typically operate on data items, right, that are separate from the procedure. So, you know, there's usually the arguments that go in there, right? So the procedures operate on data items that come in here. These data items, right, come in there. But they are usually separate from the procedures themselves, okay? So that's an important idea. So data items commonly pass from one procedure to another, right? So a function will have inputs and outputs. And so you have, you know, 3, but then this goes into y, and then you have another f2, and then this takes y, and it gives you, you know, k, let's say. So as you know, you're just passing information. So it basically functions have inputs and outputs. That's really the idea. All right. And then the focus is to create procedures that operate on the program's data. So they're kind of independent, standalone functions. And that's kind of what you have done. Object-oriented programming will be a little bit different from this because it's a much bigger container of things, right? And you can have multiple functions in there that could be related to each other conceptually somehow. In object-oriented programming, as stated here, right? Basically, object-oriented programming is focused on creating objects. And an object is really just an abstract thing. So you're going to say, I want an object in my program that is people. And then you're going to think, okay, what information is associated with people? Lots of things, right? And what methods might be, or rather like payroll, right? Employees. So if you're talking about employees, then you specifically have certain tasks like salary, hours worked, information about their pension, their health care, all those kinds of things. And so all that information goes together on a per person basis. And so that's the idea, is that you want to create this container that can hold all this information. Okay, so the object is the entity that contains data and procedures. So notice that you can have in there, for instance, in an object called employees, you can have a variable called salary, which is associated with that employee, but also a function in there to calculate the federal taxes, right? So federal taxes are going to be based on the salary and the rate and everything, but it's actually a calculation. So there's a function in there for that. So, so basically the entity that contains data and procedures. The data is known as data attributes, and procedures are known as methods, right? So they're functions basically. And methods perform operations on the data attributes. And then basically this takes us to when we talk about object-oriented programming, we have to think of another concept down here called encapsulation. And that's the idea, is that it's like a container. You're building an abstract container. Just like in your mind, you have an abstract container about your family, right? So in your mind, okay, my family, okay, boom, I know everything that's associated with that, your siblings, your parents, loved ones, etc. So you have all that information encapsulated in there, okay? And so you can have an object then called family, and that would have, then you think about the variables that belong in there and the methods that you would need, right? So anything can be, but the idea of encapsulation is that you create a structure that allows you to combine data and code into a single object, where all of these are associated in some way by the abstract concept, right? And then that takes us to, okay, in Python, how do we do that? We need to have some kind of a structure, right? We need to have some kind of a construct that allows us to build this encapsulation. Okay, and so that, that's really, then that takes us to the syntax. So here we can see an object, an abstract object that we're thinking about can contain data attributes and also methods. Okay, so we create an object, let's say we haven't even given it a name, but the object has these attributes, which are variables. They could be lists, they could be dictionaries, right? Any structure that we've used so far can be in there. And in fact, usually, you'll have things like dictionaries and lists. And then you have the methods, right? You have the methods that operate on the data attributes. And these are just going to be functions. So this is going to be several lines of code. In a function. Okay, so that's an important idea there. All right, so object-oriented programming, there's several ideas associated with this. One of them is data hiding. Right, data hiding. And objects' data attributes are hidden from code outside of the object. So that is to say they only exist within the object. So you no longer have these variables available for everything in your code. Instead, if you want to get to those variables, you have to go through the encapsulation of the object itself. So access will be restricted to the object's method. So in essence, you'll have a variable and only the functions within that encapsulation will be able to access those variables. And this is helpful in many ways. Here are some examples. It protects from accidental corruption. Outside code does not need to know internal structure of the object, so it just makes your programming easier, because once you've defined how an object should work, hopefully it'll be intuitive, and then you can just use that object whenever you need to, without having to worry about all the code that's in there. So that's the example, for instance, of the math library, right? So we've used a math library. Now, you know that math has a lot of equations and things like that. But you'd really just call math dot something, right? So you did math dot absolute value, math dot, dot product, math, whatever. And all of these methods within the math object are abstracted to you. So you don't really have to worry about the code there. And so it makes your life a lot easier. And that's achieved through this idea of object-oriented programming. Any questions so far? All right, doesn't sound like you have any questions. Okay, so there's also object reusability. All right, this, this is an extension of modular programming that we had talked before, how I said to you guys, if you have modular programming, you can reuse the functions. So with object reusability, it's kind of it's taking it to the next level, right? Taking it to the next level. So the same object can be used with object reusability. The same object can be used in different programs. Okay. So in object reusability, the same object can be used in different programs. You can always just bring in that class, as it's called, and then create instances of it in your programs. Okay, and you can always reuse it. So for example, you create a class for a 3D image object, and it can be used for architecture and game programming. Right, so all of you, I'm sure, have played video games, and you guys, let's say you play the first-person shooter game. Well, you know that mesh of that first-person shooter, that must have a lot of information, right? There's so much detail, not just in the way the character looks, but also in the actions that the character takes, etc. So all of that can be contained within a class. Now, let's say that you're playing the, the team distributed first-person shooter, where you have your friends playing from home, or you're playing Fortnite or whatever, one of those games. So now you create another shooter, right? But the shooter will have the same characteristics as the other shooter, except that, the clothes might change, the weapons, powers, whatever they have, right? Where do you change that? Well, you have an object, right? The object is a general object for shooters, but then you can tweak the parameters, you can tweak the functions to make them more unique. And so that's really the idea here. So that's why you have reusability, because it makes coding of these shooters very easy. You build one class, and then after that, you just call that instance every time. Okay. Right. So so here there's a diagram. It's a code outside the object interacts with object's methods. Okay. So, and that's basically it. So you have the attributes here. This is code outside, but to get to these, right, you can only do it through the through the functions. Okay. So you can only do it through the functions. And that's kind of, excuse me, and that's kind of the idea. All right. So an everyday example of an object, so let's say you have, let's say, I guess we're gonna do an object of a clock. Right, so it could be anything. It could be a chicken, a dog, a phone, a lamp, whatever, so there's no limit to this. So, basically the example of a clock object, right? So what are the things that it's going to have? So it's going to have some kind of a state, right? You're going to define the state of the clock. That means you need to have a variable for seconds, a variable for minutes, and a variable for hours, right? And these are called the data attributes. So you have that. Then you also have some methods, all right? So in this case, public methods, okay? So they allow external code to manipulate the object. So these could be methods such as set time, set alarm time, get time, right? So these are the things that you probably want from the outside to access in your object clock. And then you have private methods, which are used for the object's inner workings. Right, so inside the clock, you're going to have, you might have some variables, right? Some internal variables that you don't need to change that much, right? They're just there by default, okay? So that's really the idea. So you have some methods and variables, and they're part of that encapsulation. Now that takes us now to the keyword. So this is the keyword, or what could also be called the reserved word, right? So it's basically the word that you're going to use now to build these objects in Python, okay? So that's usually, and in most programming languages, that is going to be called the class, okay? Defining a class. So a class is code that specifies the data attributes and methods of a particular type of object that you thought of, okay? So, and I said this before, it's similar to a blueprint of a house or a cookie cutter. right? So it's just something, some idea of how things are going to work. And then after you've defined, so here you define, and then here you create. And so in create, basically where you define the class, in create, you're going to set up an instance, right? An object created from a class, right? So that's the instance. It's similar to a specific house, built according to the blueprint or a specific cookie. There can be many instances of one class, and that's what I said with the games, right? So let's say that all of you in this class wanted to play Fortnite, right? And you're all going to be the same character. I don't know, Roadrunner, something. So basically what happens in the program is there is a class called Roadrunner. And so you all access that. That's the definition of it, the class. It'll have variables and methods where you can define, whatever you want Roadrunner to be, more advanced, as I said, weapons, how fast, etc. And then after that, as you start playing the game in the program behind the scenes, for every user, you're going to get an instance of that Roadrunner. So that way, the game will be able to instantiate and also to render all these different characters, right? All these different characters. Any questions about that? Okay. Questions? All right. So I know this is one topic. We haven't gotten to code yet because, like I said, it's a very abstract topic, but it's extremely powerful. I mean, I can't stress how important this will be in the future. You guys know that, in technology, in IT in particular, the way computing changes and the industry changes, the only constant is that you're going to be writing scripts and writing code. And so eventually you will come across code like this, or you will have to write code like this. And that's fine. That's what gives you the skills that are important to have in the 21st century, in these crazy times we are living in. All right, so you have then, the classes, right? So you have the classes, and that's the structure that allows you to define whatever object you want to build. And then after that, you'll see how easy it is to just create an instance of that object based on the definition and use it, which is the most important thing. And you'll see it's actually really powerful. All right, so here's another diagram to kind of illustrate this. It's kind of what I had said. I think I talked about a boat. So I talked about a boat, but they're talking about houses. All right, so a blueprint and houses built from the blueprint. So here is the blueprint that describes a house, and I'm sure you've seen blueprints of houses, first story, second, main floor, all that. And then from there, let's say that, your parents buy a plot in the same neighborhood, right? And then, your siblings, one of them buys the next one, and then guess what? Somehow you get the third one. So the three of you are in the same neighborhood next to each other. And you get an architect, and the architect builds you the blueprint, but then you all just want to use that same blueprint. You don't want to pay for different architects. So guess what? Construction workers, that would be the Python program, will build an instance, a second instance, and a third instance, right? And they're basically the same blueprint, but because there's attributes and methods, they can be slightly different, right? So they can be slightly different. So this one, has like a red door, whereas this one has a red roof. you know, and then this one has red little roofs, right? So, or other colors. So you can change those parameters, and that's how you do it. Okay. And every time you create an instance. So the idea is, so now I'm sort of in pseudocode. I'm going to say, first, I'm going to say class blueprint. Right, oops. Blueprint. Right, and what does that contain? It contains, let's say, color roof. And then what is it? Color door. And the other one was the little roofs. I don't know, color tiny roof. Okay, and initially you can have these just initialized to 0, or they can be Boolean, they can be whatever you want it to be, right? So they're initialized to that. And then inside you also have a method, you know, and you're gonna say in this method, change roof. You see that? You have that method associated in it. That method has code. What would the code say basically? It would say that variable color roof, and you change it to whatever A is. You see that? And that's really what you're doing. That's the blueprint. Then in the creating an instance of the blueprint, we go on the other side and we can say, okay, I have my blueprint. Now I want to create houses. So usually what you do is you'll say house 1 equal new blueprint. And then that's it. You just created this house now exists, right? At least in the code and memory. Then you do house 2. So this is house 2. And guess what? You just do new blueprint. And then guess what? You have a third house, so you do house number 3, new blueprint. Okay? And so this is creating the instances. So this is creating the instances. And then this is the definition of the class. If you wanna call it making the blueprints, that's fine. Obviously, this name can be whatever you want it to be. So it would probably make sense to call it house blueprint, you know, something like that. Any questions? No questions? Okay. All right, so now we have this diagram here. So again, the cookie cutter metaphor, right? So instead of blueprint, now cookie cutter. Cookie cutter, and that's a metaphor here. So the idea is you have the cookie cutter, that's again the definition, and then you have the instances. You create cookie 1, cookie 2, cookie 3. Okay? And so that's basically the idea there. All right, so cookie cutter, C1, C2, C3, those are the cookies. Similar to the previous one. All right, so now we go back to this idea of classes. You know, the keyword. So here's another example. Now we're going to have a class called insect. So you know there's millions of types of insects out there, and they have similarities, right? They have similarities. All insects, we think of them as having similarities. They're small. A lot of them fly. You know, they're usually annoying things, but they're important to the ecosystem. So there's, you know, both of those things. So we can think of a lot of insects out there, you know, the housefly, the mosquito, right? And so we can think of the housefly and the mosquito objects which would be instances of a general class called insect, right? So that's something else that we could build, because we know at the end of the day, they have certain variables and they would have then certain functions that could be associated with these insects, right? So for instance, if you were building a robot that was, or in a video game, an insect, right? Let's say that you have flies or insects in a video game. Well, you're going to create, you know that they'll have similar things like size, speed, you know, how do they, and then the methods would be like, how fast do they flap their wings, you know, if they have wings, that kind of thing, okay? So you can see it's actually pretty straightforward, you know, what you have available. And then obviously there's a lot of additional, the main concept of object-oriented, I think, is quite simple. And it's only the additional little things that provide efficiencies that make them a little bit more complex, I would say. So the insect class describes the data attributes and methods that a particular type of object may have, right? So, you know, I already said that. So let's say we create the insect class. And then from there, we can create instances of the insect class, such as the housefly object and the mosquito object, right? So that's really the idea there. All right, so the housefly object is an instance of the insect class. It has the data attributes and methods described by the insect class. The mosquito object is an instance of the insect class. It has, again, the data attributes and methods described by the insect class. Okay, so that's pretty important. Okay. So class definitions. So now we're starting to get closer into the actual syntax in Python. So you can see there is the all very powerful word class. So class definition is going to be, as you already know in Python, a set of statements that defines a class's methods and data attributes. The format is basically that you begin with the keyword class. Obviously, you use indentation. You have to give your class a name. So that's going to, you know, as you saw me called house blueprint or insect or donut or payroll, whatever you want to call it, whatever you want to create, you know, you can say Rembrandt painting, right? You know, that could be a class. Why not? I mean, it's anything, any abstract thing that you can think of that's going to help your programming to be much more efficient. All right, so so you do the class definition, set of statements that defines a class's methods and data attributes. You have, you know, the class over here, and then you have the class name. And then, of course, colon, you know, just like you do with a function, you use colon here in the same context. Okay, so so class names often start with uppercase letter. That's up to you. That's a convention. I think, yeah, you can do that. I mean, whatever is more descriptive. Obviously, keep the names descriptive, but short as much as possible. However, in Python, it doesn't really matter because you can always rename something sort of on the fly, and so that's very handy. The method definition, like any other Python function. definition. There's not going to be any differences in the way that you do the attributes or the functions. However, there will be, classes do have a little thing, a little quirk that you will see and you'll be like, oh, what is this? All right, and that is basically something called the self parameter. Self is a reserved word in Python, okay? It's a reserved word in Python used, for these types of classes. And what it does is, it is a reference that you can always have within a class. Within your class, you can always say self this. And what that means is that when the class is instantiated, whenever you make a reference to self, you mean that instance. So for instance, if I create, first person shooter 1 and first person shooter 2, each of them in the class definition have the word self. Whenever that self is used for whatever reason inside those two, it means that they refer to anything associated with that current instance. So if I'm in first person shooter 2, and I somehow do something that involves the word self, I mean, okay, attributes and methods associated with this second person shooter or person shooter, or what is it? First person shooter 2. Okay, so that's really the idea. So self is a keyword. It's the kind of thing that through doing examples and practice, it'll become a little bit more obvious. Okay, so let's see the formal definition here. So self is the self parameter, basically. It's really like a type of variable. It's required in every method in the class, and it basically references the specific object that the method is working on. Exactly. So, and it just refers to itself. This is an object. This is an object. When I say self, I reference that specific object that my method is working on. So if you've looked at programming before, if you've maybe talked about programming, so you've probably heard of a few other things associated with classes that are very famous. One is called usually the constructor. Or the constructor method. Here you can see it's basically an initializer method. And that basically implies that it's something that is used every time that you create an instance for the first time. So usually when you create an instance for the first time, you probably want to initialize it to a certain set of values. So like I was saying, so first person shooter, second person shooter, but one will have a sword, one will have a hammer, Thor's hammer versus Thor's axe, right? So that's a tool that you need to specify initially as you start the game. And so it's handy when you define a class that you have a constructor associated with it, because then when you create the instance of your two players, player 1, player 2, you can just easily say at the moment that you initialize, oh, and by the way, the weapon is hammer. Oh, and by the way, for player 2, the weapon is Thor's axe or something like that. Okay, so you have these different parameters, and that means that the class usually will have an initializer method, usually, as I said, referred to as the constructor. Basically, what it does is that it's automatically executed when an instance of the class is created. So automatically executed when an instance of the class is created. Okay. It initializes objects, data attributes, as I said, like the hammer or the axe, and basically assigns self parameter to the object that was just created. So this is where you create that reference, right? So now you're going to have self imagine as a place in memory. And then now you created also, let's say, the instance. And so now self is referencing that same instance. So, you know, this is something that, don't worry if you don't get it right away. It's a little bit tricky to get, but you do get it with practice. And you start to understand why. So it initializes objects, data attributes, okay, and assigns the self parameter to the object that was just created. And that's done through the constructor. So now we can look at the syntax, and you can see here basically within the class, you're going to define a function. You see we use the word def, but it is a special function with a reserved name that already exists, which is this one. And this will probably look strange to you, but the way that this is written is define. This is actually 2 underscores. So it's actually 1 underscore and a second underscore that just look like 1, but there's two of them. Then you write the word init, and then again 2 underscores. They just look like 1. And then in the parentheses, you say self, and that allows you then that whenever you use that instance, you know, the self parameter is associated with that instance. And then, of course, your code will be here, whatever you want it to be. Usually the first method, and it's usually the first method in a class definition, okay? First method in a class definition. Questions so far? All right, so let's look at, here's a diagram of what we were talking about with the constructor. You can see it there. You know, there it is, def init self. So then it's basically an object. An object is created in memory. So an object is created in memory. Oops. An object is created in memory from the coin class. So you have a coin definition, and then you create an object. So there it is, a coin object. Then the coin class has the init function, the constructor, which is a method. That one is, when you create the instance, is called. And then basically the self parameter is set to the newly created object, right? So it's going to be, so self is like, it's linked to that now, okay? And then within it now, then you can say self dot whatever, and that just means that for this object, I am accessing some attribute, in this case, side up, and guess what? I'm going to initialize it always to heads, because you could also initialize it to tails, right? It just depends on how you're going to do it for your game or whatever it is that you're building. And then finally here, once you've done this, you look at, after these steps take place, a coin object will exist in its side up attribute, with its side up attribute set to heads. So you can see that there, side up, and now it's assigned heads. Okay, and that's the basic idea. So now we continue with the syntax in Python of class definitions. So to create a new instance of a class, you call the initializer method, right? So you saw here, the format is my instance, so for instance, house1 equal, and then the class name. So in this case, let's say house blueprint. Okay. So that's really the idea. To call any of the class methods, so to call any of the class methods using the created instance, you're going to use the dot notation, right? The dot notation, which just basically means, quite simply, that little period. And you've done this before, I think. We did this with pickle, I believe, on Tuesday. Pickle read, pickle write, something like that. So same thing here. So let's say that now you want to calculate what's the square footage of your house, and you have a method called square footage. So then you would just say house1 dot, whatever you called it, square feet. And then that will return, so you put that in a print statement, and that will return the square footage, because there's a method that calculates that based on the internal variables. So to call any of the class methods using the created instant, you use the dot product, and you can see that there. And here is the specific format. Because the self parameter references the specific instance of the object, the method will affect this instance only. Okay, so that's how it knows. And so reference itself is passed automatically because it is within that instance. All right, then after that, there's a few other concepts, that vary based on programming languages, like Java, for instance. Other programming languages have more strict rules on how you set up classes. Python, I think, you don't have to be so strict with everything that you do in Python. But basically, there's a few additional concepts here that might be a little bit more general. So for instance, an object's data attributes should be private. To make sure of this, you place two underscores in front of attribute name. So if I had a variable like roof, door, if I put two underscores within a class of that variable, it automatically makes that variable private. And what that means is that these become hidden, basically, or they become only accessible to code within it in a very strict way. So you can't just access the attribute from the outside through the object. You have to access it through a function in the method. Now, one thing that's very handy is that classes can be stored in modules. What that means is you can actually, so far in this semester, we've only used one file for all of our code. As it turns out, you can break out your code into multiple files. And then the thing is, to bring in code from one file into the code of another file, you just have to use the import. So just like you did import pickle, to bring in the pickle module, well, if you create my own module, then you could say import my own module, and then all that code will become available. So it just has to be that usually the name of the class has to match the name of the file. And then that's about it. So the file name for module must end in .py, okay? And then that way the module can be imported to programs that use the class. So that's important too, the name of the extension. But that's really, all it is. Any questions so far? No questions? All right, so then let's more about classes, basically. Another example of using a class here. Let's read through this one. It's a bank account class. All right, so class methods can have multiple parameters in addition to self. For init, parameters need to create an instance of the class. Example, a bank account object is created with a balance. All right, so when called, the initializer method receives a value to be assigned to a balance attribute. So you have, for instance, you know, a class bank account, and then you have your customers. So every single one of your customers would get an instance of that class, and then they need to be initialized with a balance. Because you might be reading that data from a database, but then you load it into your code for whatever reason. For other methods, parameters needed need to perform let's see what it says. For other methods, parameters needed. Okay, so I think what that is trying to say is that you also have for other methods, right? Like the deposit method, you need to have parameters associated with them, so they're needed. So for instance, if you're going to deposit something and the code is going to issue a deposit, that you need to know what the amount of the deposit is going to be. Okay, so just a few more things here. Now, some of these things from these slides on, you know, you don't always use. Okay, so these slides are just being very descriptive of all the things that are available in objects. You won't see me using all of this. I would recommend a constructor, but even a constructor, you can create a program without it. However, some things are, you know, much more common to use than others. So now there's the str method, all right? Basically the object state, the values of the object's attributes at a given moment, right? So that's could be handy, right? You have an object and it's changing a lot, but at one specific moment, you want to know the state of the object, which basically means printing out the values of the object's attributes at a given moment. And that's called the str method. This again is 2 underscores. All right, so this displays the object's state. It's automatically called when the object is passed as an argument to the print function, right? So it'll just give you like a type of a data structure. It automatically called when the object is passed as an argument to the str function, the string function. So both of those. And it's something that you might not even see, but it's behind the scenes. All right, so now working with instances. So what this is saying is that when you have, if many instances of a class are created, each would have its own set of attributes. So I think that's probably obvious. Yeah, so. I think I've said this before. I don't know. The wording here seems strange, but this we've talked about is just the, you know, I think it's summarized there. And many, if many instances of a class are created, each would have its own set of attributes, basically. All right. So here we have, for instance, an example, coin 1, coin 2, coin 3 variables. And so you have coin 1, and each one of these instances has its own self, right? And then each one has the attribute side up that belongs to itself, and the value is heads. And then that can be changed after you have a method in there, toss. Let's say what the method toss would do is it grabs side up again, and it kind of, I guess, it randomly assigns heads or tails. So first two are assigned tails, the last one was assigned heads. Okay, so it would seem like it didn't change, but in fact there was a toss method. Oops, there was a toss method or function, and that one was used to change the values. All right, so all right, so now all right, so now let's move on to the next slide. Let's see. Okay, so these are more advanced concepts. Let's see if we want to cover these. Yeah, so these are just, these are just fancy names, I would say, for something pretty intuitive. When you have private variables, those that have those two little underscores, whenever you want to modify them or whenever you want to view them, you create methods. And those methods can have any name that you want them, but usually they could be referred to as accessor and mutator methods. So typically, as it states here, all of a class's data attributes are private and provide methods to access and change them. So for instance, an accessor method would return a value from a class's attribute without changing it. That's pretty obvious, I think. And it's a safe way to code outside the class to retrieve the value of its attributes. And then the mutator object method stores or changes the value of a data attribute. So this is something like if you have a class weather, and then within it you have temperature, but to access that value, and let's say it's 70 degrees. If you want to change that, you wouldn't just directly access temperature. Instead, you would have to say something like, you have weather 1 as new weather. And then when you want to look at the value, print the weather, you would have to say something like weather show temp. Right? And so that show temp will access that temp. And the same goes for changing the value. You could say something like weather update temp. And this time you're going to say 80 degrees. Okay, so that's really the idea. That's what that means with these accessor and mutator methods. Okay. Now, objects. One of the very handy things about object-oriented programming is that now you create an object that has a lot of information associated with it. Right? You have attributes, functions. And so in a sense, as your data is flowing in your program and you're building much more complex architectures, you can actually just pass the objects themselves as attributes. So you could create, for instance, in the first-person shooter game, you could create a list of players. And inside the list, what you have is, instead of having strings, integers, or whatever, you would have objects in there. You can have, you know, eight players, so you'd have 8 objects, and now you can iterate through the objects. You can constantly check what they're doing, you know, and update them. And so that's something that is useful. So that's what, you know, when you say passing objects as arguments, sometimes methods and functions often need to accept objects as arguments. Okay, that's what I just said. So when you pass an object as an argument, and I should say the instance of a class, right, which is an object. So when you pass an object as an argument, you're actually passing a reference to the object itself, right? So you might, you know, it's really like an address or a pointer. And then the receiving method or function has access to the actual object. And then methods of the object can be called within the receiving function or method, and data attributes may be changed using mutator methods. So that's actually quite useful, right? It's a little bit advanced, and I'm not sure that you guys are going to need to implement that in the project. However, there might be a need for that depending on your project. And that's why, you know, as we go into the breakout rooms at some point, you know, we will talk about how to add that in. Okay. All right, so let's see where we are on these slides. All right, so I still have quite a few. Yeah, let's finish these, I guess. Okay, so I've talked about that. Now, techniques for designing classes. You know, there's a diagram, the UML diagram. So there's standard diagrams for graphically depicting object-oriented systems, which stands for the Unified Modeling Language. I'm not going to make you guys do this. So that's definitely, you know, I'm only kind of just sort of getting you into classes, so I don't want to overwhelm you. And this just talks about the general layout, box divided into 3 sections, top section, middle section, and bottom section, where you have the name of the class, list of data attributes, list of class methods. And you can see that there. But as I said, this is not something that I'm going to stress so much. All right, now when developing an object-oriented program, first goal is to identify the classes, right? So this is kind of the procedure. So you typically involves identifying the real-world objects that are in the problem. You know, that's something that you will do for the project, right? Specific to your term project, what are the objects? As technique for identifying classes, so you want to get a written description of a problem domain. Maybe identify all nouns. That might be a good trick, right? So, okay, I look at nouns, and are those my objects? Each of which is a potential class. Not every noun needs to be an object. Usually, you'll start with one class, and then if you need more, you'll create more, right? But you know, don't think that every noun has to be a class. And then you'll continue to refine the list to include only classes that are relevant to your problem. So finding the classes in a problem, you know, get a written description of the problem domain. Should include any of the following: physical objects simulated by the program, the role played by a person, the results of a business event, record-keeping items. Right? So these are actually good recommendations on how to start to try to find your objects for your class to be defined. Identifying all nouns in the description, each of which is a potential class. Should include noun phrases, you know, like a cat, the sleepy cat, right? So those are noun phrases, and pronouns. So find, you know, pronouns as well. Some nouns may be repeated twice, you know, things like that. But in general, just nouns. That's kind of what it comes down to. And then you want to refine the list to include only classes that are relevant to the problem. So remove nouns that mean the same thing. Remove nouns that represent items that the program does not need to be concerned with, right? So you're talking about payroll, and then in your description you said something about the customer, but the customer is not relevant to the payroll that you're trying to figure out, right? The code. So that's the process. So remove nouns that represent objects, not classes, and then remove nouns that represent simple values that can be assigned to a variable. And so that can happen as well. Okay. Identifying a class's responsibilities. So a class's responsibilities are the things the class is responsible for knowing. So identifying these helps identify the class's data attributes. So what is it that you need to know about the payroll, right? So, you know, that kind of thing. And then what are the actions that you need to take? So usually, like temperature is a good example, right? You have a class temperature. So you're going to have, or weather, sorry. So weather, you know, you're going to have variables like wind, temperature, dew point, you know, density, altitude, you know, all kinds of things like that. And then to calculate, you know, maybe you have temperature in Celsius, but then you want to report it in Fahrenheit, right? So then you might have a method in there that's going to be the action to take that just takes whatever the Celsius is and converts it to Fahrenheit. To find out a class's responsibilities, look at the problem domain. Then deduce required information and actions. All right, so these are the slides. So we've definitely gone over these, all these topics today, and that kind of concludes the slides for today, the slides portion. Okay, now next week we'll cover a topic called inheritance. I'm not going to cover that in too much detail because it's an advanced topic. You can see it here. Cover a little bit of that, and then, as I said, I'll introduce yet another topic to work on. So now what we should probably do is open up the Jupyter Notebook. So I'm going to hit stop share here. Okay, and I'm going to open up the Jupyter Notebook. All right, and then I'm going to create a new Python 3. All right, so let me share this. You guys, you should be seeing at this point the Jupyter Notebook that I have. All right, so now we need to think of some type of an object that we want to create. So that's basically what we're going to try to think about. All right, so let's see. All right, so we're going to create a very simple class, okay? And it's going to be, what would it be? Let's start with something simple like product. Okay, we're going to say product. So the way that you do a class is class, right? And then I'm going to give it I'm going to call it my product. Right, so you should be seeing right now. I'm typing on the Jupyter Notebook, and I'm creating the class object. Product over here, and then colon. And that's basically it. That defines the class. Now I can start writing aspects about it, right? So the first thing is the constructor. So I'm going to say define, the 2 underscores init, 2 underscores, and then here I'm going to plug in the variable self. Okay, self is that variable that we had talked about that just has to be in every method. Okay, so for now, just remember that self has to be in there. Now, whenever you pass arguments to the function, you might pass, you know, this might have several arguments, but you always, as part of the arguments, you always have the self. It's just that it's something that you don't account in the number of arguments that you have, okay? But, you know, that we'll talk about that in a sec. So here, you know, for instance, when I do the instance, so here I'm just going to initialize, you know, variable 1, let's say, for now. So it's my product. That means that it's, you know, like hammers and nails. So I'm going to create attributes. So I do self dot, you know, name, product name, right? And it's going to be, I'm going to initialize it to nothing. And then I can do self dot quantity, you know, like quantity on hand. And that's going to be a number. So right now, let's just say it's 0. And then I'm going to say, so you notice I can't do this. I have to do self dot price, right? And then that's going to be some amount, but I'm just going to initialize it to 0.0, right? And that should be enough for now. So that's the constructor, which allows me to set up the variables for that instance. Now the variables, because they don't have to be up here. Notice they can be in this function, or they could also be over here. But it doesn't matter because they all have the word self in front of them. So they're really linked to that self, and that makes it convenient to know that they just belong to that instance. All right, and then once you do that, then we can start defining little functions for this. Right, so we can say, for instance, now we want a function. So now I'm going to create another, you know, definition here, and because these are products, let's say I want to calculate. So let's say there's going to be I have quantity and price, and let's say I'm going to have tax, right? And so the tax is just going to be a tax rate, which also I'm going to set later. And so then I can define a function here called calculate total, right? So calc total. And notice it doesn't need to have any arguments because it is part of this, my product. I can just easily reference it, and it's going to use all these values. So then I'm going to say, well, calculate total. So total will be whatever the, so let's say total, right? This one does not need to be self because this is just a variable that I'm going to return. But the ones I'm going to reference, like self.quantity, okay? So I need to say, okay, what is the quantity times the price, right? So if something, if I have buy 3 of something that costs $5, that's $15, okay? So self price. And then I also want to, so this should be subtotal actually. Subtotal. And then once I have this, I can calculate total just by saying total equal subtotal time, or sorry, plus subtotal times self dot tax, right? Because that's going to be the tax rate, and that would give me the total. So then all I have to do in this function, as we've done before, is I'm going to return, return that value. So I'm going to return total, and that's it. And then you can have as many functions as you want in here. You don't just have to have, but you've created the class object, right? So now I'm going to go ahead and create a little line here. All right, so I'm going to create a line, and now I need to create the instance of this, right? So I need to create the instance. So I'm going to go, I'm going to go here, and I need to create, first of all, I need to create an instance. So I'm going to create, you know, a product and it's going to be called hammer, for instance. It can be any name that I want it to be, right? So I'm going to just create my product, right, hammer. And then now I'm going to give it the information that's required. Now, how do I pass that information? I need to define that in the constructor itself. Okay, so if I go to the constructor, I can set the parameters. I don't have to set them in the class. I can just set them here. So I'm going to say, for instance, here, name, comma, quantity, comma, price, comma, and tax, right? So these are the 4 parameters that I'm passing. Notice that really there's 5 here with the self, but when I make a call to the class over here, I don't have to specify self. So I can really just start with name, quantity, price, and tax. So there's going to be 4 arguments. So the first one will be hammer, right? And I actually then, because I give it the name there, I don't have to call this one hammer. I can just call it product 1. All right, so I'm going to do my product hammer, comma, that's the name. The quantity, let's say that I have, I'm buying 10 hammers. And then I'm going to say that the price of the hammer is $5. So that's going to be $50, 5.0. And then the last thing is the tax rate. So we're going to say that the tax rate is like 0.07 or something. All right, and that's it. So I've defined the class over here. And then here I define an instance of the class with product 1, my product. Okay. And that's basically it. So let's just run this code. Let's see what happens. I'm going to run it. You see it, it worked fine. So now what I can do is I want to calculate the total and print it. So it's very simple. I just say print, and I'm going to say what? Product 1, and I'm going to do dot this one, calc total, right? So I'm going to do calc, oops, not there. So I'm going to do product 1 dot calc total. Okay, so that's basically the idea there. You know, I try to run my functions like that. Does that make sense, guys? So now, if everything worked out, we should be able to print out the total, which is 10 times 5 is 50. And then 7% of 50 is what? 3.5, so it should return 5350, right? So that should be our answer. So let's go ahead and run it and see if it works. And it doesn't like it. Okay, let's see. So it takes so the error is in my product. It takes how many? Type error calc total. Take 0 positional arguments, but 1 was given. Oh, I know what it is. And this, you know, this is a common mistake. So you guys will make that one as well. I said this, but yet I didn't implement it. So let me clear this up. Here, remember, here in this function, I am referencing things like self.quantity, self.tax, and so on, yet I did not pass the self parameter. So that's what I was saying. So even though you don't use it, that's something that you will miss, right? So notice that needs to be in there. Okay. So let's try this again. And it doesn't like it. There's no attribute quantity. Oh, that's a typo. Quantity. Oh, and I have another error here, right? The fact that I never initialize these to anything. So that needs to be changed. That needs to be name. This would be quantity. And this one needs to be price. And then this one needs to be tax. Okay, so now I've done the actual assignment. Okay, I've changed the spelling. Hopefully that'll work. All right, so let's try this one more time. Ah, there it is, 5350. So you can see now I was able to get the answer, 5350. So a couple of things that are important. You know, this is the very basic class that you can have. I would suggest you just do something like this for your term project. But I want you to think about a specific item, right? Then you'll have your constructor where you take some parameters here, initialize the variables. That's done the second the instance is created. And then I have some set of functions to calculate things like calc total. But it's very handy because, why is this handy? Look at what I can do now. I have all these products, right? What are some products that you would have in the store? What are some products? Guys, some products?
Apples.
Apples, right? So then, you know, I'm going to create, you know, product 2, product 3, oops, product 4. Look at how efficient this is. That I just had to create that code one time, and now I have all these instances, right? But they're all pretty much the same code. I'm reusing a lot of the code, right? 4, 5, 6, right? And now I just, you know, you said apple, right? So apples. And I have, let's say you sell it by bags or whatever. So it's going to be, you know, 4 bags. And they cost like $2. And the tax rate is the same, right? So now I can calculate, what's another product? Right, so juice, right? So oops. Juice, right? And juice would be 2 carts and say $7 and same tax rate, right? And then just a few more, let's say nails. Chips, I can see you guys are hungry. All you're saying is food. So nails would be another one. What was it? Chips, right? Chips. And then, you know, pencil. So you just have one pencil. It's like $1, let's say. And then you have chips. I don't know, you probably get 1 bag. $5 is okay. And then nails. You get 6 bags of nail or 16 bags of nails. Why not? Right, and they cost, you know, $4. And they'll have the same tax rate. So you just changed the values. You didn't really have to change anything else. And now if we go ahead and run it, guess what? You know, easily you can calculate all the products without having to worry about anything, right? You see how handy that can be? guys? Yeah. Another trick we can do is, I don't hear any questions. So another trick that we can do is I'm going to create my list of objects, or it could be products. And guess what? I'm just going to say product 1, product 2, product 3. I'm just going to do 3, but you can do as many as you want. So I took the objects and now I put them in a list. And then I can do for my object in list objects, right? So I'm going to iterate through these. And then what do I want to do? I want to just print the object. Instead of having to do all those print statements, I'm just going to say my object, every iteration, it should change, my object dot calc total. All right. And so, but also I want to say print my object dot name. All right, so now let's go ahead and take a look at this one. Space there. Okay, so we're going to run this again. And you can see here, it printed out the names. I forgot the parentheses here. Adding the parentheses now. All right. Run it again. And you can see now it calculated. It gave me, you know, hammer, the price, apples, the price, juice, the price, right? So, and instead of having to imagine this is fine if I just have 6 products, but if in an inventory system of a hardware store or a supermarket or a general store, you're going to have thousands of items, right? So you really don't want to have to do it like that. Instead, you know, a nice little for loop like this will do a lot better. And that's it. That's, you know, that's as far as I want you guys to go with object-oriented programming in your term project. Okay, I'm not really asking for much more than this. But of course, this will have to be specific to your term project that you're doing, okay? So it'll be specific to that. So what we're gonna do, you know, now we're kind of out of time for today. So basically today was just a lecture. What we will do on Monday, or sorry, Tuesday next week is that just, you know, practice this on your own, get together with your teammates, right? Start thinking about this again. And then on Tuesday, I'll do a short lecture on anything else that's still missing. And then after that, we'll do the breakout rooms and you guys can show me what your idea is about how you are implementing your object-oriented code for the term project. Are there any questions?
Yes, I have a question. Is the GitHub, what's it called? The GitHub video out on Brightspace, or is it not out yet?
I asked Mitch to create it. So give I think by Friday, sometime by Friday, it'll be posted on and it will be posted on YouTube, on the YouTube channel.
Okay.
But he's working on it, so I did ask him to do it, and he said he was, you know, happy to do it. So he'll be doing it in the next couple of days. Make sense? Any other questions? No questions, guys? All right, so again, as I said, no homework, but that's only because I expect you to be working on the term project, right? So now you have a new thing to try to add to your term project. I want you to think of, we've gone over the lecture, I've given you examples. Now try to implement this in your term project, okay? All right, so I'm going to pause the recording now. I don't hear any questions. I'll stay for a couple of minutes.